And we are live. Welcome back to our YouTube channel. And this is the third episode in the Creative Coding series with Kotlin. And for the second time, we have Edwin here as a guest to demonstrate some cool features of OpenRender. Hello, Edwin.
Hi.
Hi. So last time it was an amazing session. Everybody was pretty happy. We received a lot of feedback and a lot of requests to continue. And this time we're gonna look into MIDI, and I think it will be surprising for many what actually you can do with MIDI and what it really is, because I think a lot of people think of MIDI as only music or like MIDI music or MIDI files or something like that.
Yeah.
And as a matter of fact, it's much more. And today, Edwin is going to demonstrate what we can do with that in the frame of OpenRender. But I think we should start by reminding people what OpenRender is and what you can do with it. So I think you can start with that, and then we proceed with the main topic.
Yeah. So OpenRNDR is a framework for what I call creative coding. The framework is fully open source and it's written in Kotlin. It's a framework that has been developed in the RNDR studio, mostly to do a lot of my studio work, which is making interactive installations, video, and print work. Um, there's a fantastic website, openrndr.org, which showcases a lot of our work, our experiments, sketches, but also gives you like an introduction to the OpenRNDR framework. Um, we put a lot of effort into writing a guide. So if you're interested in trying out OpenRNDR for yourself, do check out the guide and check out our template project and try some for yourself. It should be pretty easy to get started. Okay, Anton, what shall we do today? Shall I just start showing around in IntelliJ
I
some
think
OpenRNDR
if you
magic?
could show a few interesting tricks like scatter with the hobby curve, just a few lines of code and see how it
Mhm.
changes life. I think it's very impressive, and this is something that people who program on the JVM don't really expect to happen when you change the program
Mhm.
and it refreshes automatically.
Yeah, that was last time was pretty interesting. Where I started with writing programs that, they have like your usual cycle. You write the code, you press run, and the software compiles, and um, it starts. It means that you have to wait a bit before you can see the results. Then I switched to a live coding mode, which means that I can write code while the program is running. I change the code, and also the output in the program immediately updates. That is something that I'm going to use today again. Um, so yeah, maybe I should just get rid of this browser window and start start working. Um, this is basically one of the files that you'll see when you get the OpenRNDR template project. This is a project that you can get from GitHub, and it provides a starting point to write OpenRNDR programs. Um, those always start with a main function in which you have an application. Inside that application block, you'll find a configure, so you can set the size of the window. I also set like a property here that is called window always on top. which is nice because then I can have IntelliJ in full screen, and I can have my window on top, and I can edit the code, and the window doesn't disappear. Here I set the position for a window. This is just like for show, because now if I start the program, it will always appear on the right spot, so I don't have to move windows around. Then there is something that is called Olive program, which stands for like OpenRNDR Live program. And basically anything that is written inside this block here, so here, this will be reloaded, and you can see the output of it immediately, right? So just to demonstrate, now the window is pink. And last time, one of my favorite things is to just draw a circle with a radius of 100, and we have the circle, so that's nice. Yeah, today I want to introduce MIDI to this whole setup, and today I have two little friends here, two MIDI controllers. One is a very old BCR 2000, which has mostly rotary controllers. So you have little rotation knobs here, and the other is in the bottom, just like your average keyboard. There's in MIDI, we'll see there's like two different events that these devices generate. So there's something that is called a control change whenever you use one of the rotary knobs, and there are events that are called note on and note off. So whenever you press a key on the keyboard, you get a note on event, and whenever you release it, you will get a note off. So today I want to show a bit like how well, first of all, how to open such a device, or first like list which devices are available, then open one, and so on. So if I use list MIDI devices for each, I just print the devices. Then what I'll see here in the bottom, just in the console, is a number of MIDI devices. So there is this one is the BCR 2000, and this K32 is this little keyboard with 32 keys. I'm gonna open I make a variable called MC, which stands for the MIDI controller here, and that will be open MIDI device, and then I copy the name that I see here into here. So that opens that device, and I'll make MK for MIDI keyboards. Do the same thing, but then I copy this part here. So, okay, it's reloaded, but nothing happens. I can rotate these things, but we don't see anything happen yet. There is like a little tool that I like to use to see what is going on. It's called the MIDI console. Actually, let's just extend MIDI console this. And in the console, we can register MC and MK. When I have done this, if I press keys, let's change this to 10. So when I press keys, you see the keys that I pressed. It says like note on 65. So this key here is key 65. If I rotate one of these rotary knobs, I get CC for control change. And we learned that this is like a rotary knob 104. And it now outputs a value of 127. And if I rotate it all the way back, it becomes a value of 0. So you have 127 values that you can use here. Yeah, let's try something simple. So I make a variable radius, which I set to 0. And then I say MC control change, listen. And then we can say if it dot control, if that's equal to 104, which is this one here, we set the radius to value, and I divide by 127, such that the radius is set to something between 0 and 1. And then here I multiply by radius. So now if I rotate this thing, we control the radius of the circle, which is, yeah, it's very simple. It works, but if you want to have like a second circle, like for radius 2, we have to write code like this. Which is basically like a duplication of what we have. We do something like this, and let's move this one circle a bit to the left. Okay. So yeah, there's now 2 of them, but I think like this is quite a bit of code that we have, and at some point you'll write like a lot of boring code just to get the controller values and put those things in a variable here. So there are some nice tools that we can use to improve this situation. Instead of using this listeners like this, we could do something. Actually, yeah, let's start with something. I make a settings is an object, and I add here this radius, and I use an annotation that is called double parameter, and that I describe what this thing is. So this is a radius, and I would like to have this radius between 0 and 100. And I also immediately make a radius 2. Okay. Then we start using settings set radius and settings set radius 2. Then we could use something like bind MIDI control settings radius, and I want this event to come from the MC, is the rotary controllers, channel 0, and this we set to 104. Okay. So this should be doing, right. This multiply by 100, take it out. Okay. I only see, this should be radius 2. Okay. Wait, let's restart this because I think we bunched up some events there. Okay. So we still have the 2 circles here, which is nice. Works in the exact same way, just a bit less code. But we see like we added all these things here. This is just to be able to tell that I want like the one extent of the rotary to match with 100, and like the lowest value should match to 0. There's like another thing that we can do now. We can make a very simple GUI for this. Okay. So now we have 2 sliders here. And if you can see it on the MIDI controller stream, you could even see that the LEDs for the controller, they move along with my slider now. So if I change the controllers here, also the user interface updates and the controller updates the other way around. So that's a really nice system for we can make a drawing. That drawing will have parameters, and I can set up the parameters to work from this user interface, but also from the MIDI controller. And yeah, there's like a double binding. So yeah, I can control both. I can control the MIDI controller from here, and I can control the slider from the MIDI controller. And that's like that's not so much work to set it up. Now there's one thing that I find a bit, it's a bit of a pity, because these MIDI controllers, they only have like 7-bit precision. And we saw that the values for every rotary knob can go from 0 to 127. So you can almost, well, in this case, not really, but in some cases you can really see it make steps. And also like the way that I rotate the knobs looks very linear, and we can easily make that a bit nicer by smoothing out the values, or and maybe introducing something like a little a spring force system. Now let's try to do something like this. So there's I make smooth radius, so I make a new value, and I use a property delegation by smoothing settings radius. I import this thing here. So instead of settings radius, I'm going to use smooth radius here. So this one, it will now take some time. I put this to full, but the circle itself will need some time to adjust to the new settings. Actually, you can even, that's smoothing. You can make a property for that you can add to both the user interface, and you can also make a binding with the MIDI controller for it.
Wow.
So like this. So now there's no smoothing, and if I set this thing to here, it will be. So now it's very slow, and
nice.
now it's faster. So which is nice, especially if you want to do things like I don't know, you want to do live visuals, animations, and you want things to look like just like a bit more natural, than no smoothing. Then it's really nice to introduce like some smoothing to make it a bit more like organic. The other thing that I mentioned before is like you could introduce something like a spring force. So it looks like the controller is attached to sort of a spring. I'll use spring radius. On this, and then the other circle I will draw with spring radius. So you see that it bounces a bit after I change the value. So yeah, let's do like some other demonstrations. Last time we showed like the scatter and the hobby curves. We can make something where I draw a hobby curve and we draw like a subpart of this curve, and we can do this with we can select the subcontour using the MIDI controller. So let's try to do this. So first we make random points using scatter. So say something like this. And then the curve will be hobby curve true points close true. So this was, oh, why is this? Well, that's inconvenient. Though this is my, I'm working with a development version of OpenRNDR, and I think I just introduced a really nice bug that is now, is now,
Happens.
it happens. Let's see if I can quickly work around this.
So, are those new features that you're demonstrating with MIDI, are they only in the development version right now, or?
Well, yes, and I am actually I was pushing a new. We do like alpha releases, so every couple of weeks there's like a new alpha release, and I was just working on one, but that one apparently now contains like a really nice bug.
Mhm.
But yeah, the features that I just demonstrated, they have been developed in very recently, so up to 2 weeks ago actually.
See.
Let's see if I can work around that little problem that we have. Yeah, okay, fixed. So the thing that I showed last time is that we can draw like a small part of this contour. Let's make a bit more points here. Oh. Okay, then I would add double parameter, add like a start.
So, do I get it right that when you bind it to the UI object, the settings panels, and generate it automatically, right? Using
Yeah,
reflection
exactly.
or something like that. Yeah.
Yeah, so we have these annotations, these double parameter annotations. So they specify like a label that should be shown in the interface and like a range for the values, such that we can make a slider for them.
All right.
And there are also some other things because if you use reflections to find the fields in a class, you will always get them back in alphabetical order. So apparently there's no way to force the order in a JVM class. So if you want a user interface,
Unless you introduce some kind of API to specify the order, right?
yeah, exactly. So in the annotation, I can set the order. So I set start and end. They have order 3 and 4, and so now they are on top because apparently the rest has.
And do you have annotations for the other kinds of parameters like toggles, like just the checkbox
Yeah,
enable,
yeah.
disable?
So yeah, so just to quickly demonstrate that. There's also like a color parameter. So if I,
Nice.
for example, would now clear instead of using a fixed pink there, I could use fill here. And then if I change here, then the color
Cool.
updates. Yeah, and then there's a toggle, but the toggle does nothing. Yeah, so let's quickly get back into drawing this this curve. So now it's just showing from 0 to 0.1, but we could use settings.start to settings.end. So now we take a smaller part of the curve. Yeah, this we can also bind to the MIDI controller. Start and end. Let's take these, and then yeah, there we go. So now we can control the, and now you see that it is really choppy. This is because I only have like 127 steps on the controller, and you see
Mm-hmm.
you see the animation is really choppy. I just can't be more precise with this controller. But if I would make a smooth start, for example, by smoothing start, and same thing. Okay, now this should be it's a bit better. Yeah, we can make it I think if the smooth factor, the default is that it is actually pretty slow, maybe a bit too slow for what we want. Yeah, so now it's good. Now it says it's like responsive, but it's not choppy anymore. Okay, well, so that's controller values. Now I would like to spend some time with the other type of event, which is the node on and the node off. So I'll be I'm going to show how to use these keys here. What's the best? I think I'm just gonna get rid of everything. Okay. Be gone. One thing that I like to do is make the UI only visible when my mouse moves to the left of the screen. So I just hide it because the bar is on top of our drawing, which is just sometimes a bit in the way. So the thing with the keys, we can the MK, which is the keyboard, we can listen for node on, and we can also listen for a node off. I'm gonna do a thing where I make a radius variable again. And if, let's see, this one is 79. If the node is equal to 79, then we set the radius to 100. And if we release the key again, and it's key 79, then we set the radius to 0 again. Okay. So now we have circle only visible when I press this key. So we could potentially we could do that same trick again, where we make this settings object. And we make...
I can think of a case when you press the note, then it appears immediately, but when you release the note, then it kind of shrinks and animates back to 0.
Yeah, so if we use that smooth radius trick again, let's change this. So we have now something like this. Let's just do. But we only have one circle, and actually, what I would like to have is something where like every key that I press here has to create a circle, and I also would like to have multiple circles visible at the same time. And for this, I made a piece of tooling, which is called an ADSR envelope. Let's see how we introduce it quickly.
ADSR stands for attack, delay.
Yeah, attack, decay, sustain, release.
Right.
So there's something that's called an ADSR tracker, and that tracker will take care of keeping track of active nodes, and for each active node, it will apply an envelope to it. What can actually what I can do here is say here tracker trigger on, and here I have to do tracker trigger off. Oh. Then let's see. Yeah, of course, times 100. So here, this, let's see, this tracker, actually, we can add the tracker to the GUI. If I do this in the right place. Okay, so I actually now we have visible attack, decay, sustain, and release value. So if I make this release much longer, if I release it now, it will take 14 seconds before it's fully faded out. Also, yeah, if I press the key multiple times now, it'll actually accumulate some of those ADSR envelopes on top of each other. But what we want is every key should make its own circle, and I made it so that we can take this out. When you trigger, you can give a trigger ID for which I will use the node, and we can also provide some code that can be executed for each of the nodes it tracks. I'll try to show that. So actually, for each node, also, yeah, let's draw a circle at something at C, which we haven't defined yet, and then we'll take value times 100. Now we can make a value called CX, which is the node minus 48, because the first node on this keyboard is 48. Plus, no, times width divided by 31. File C would be factor 2 CX and height divided by 2. And for this, take all of this out. Okay. Then what we can do using this tracker is for v in tracker values, v.draw. And there we go. Lower the release. So yeah, I can now just do this, and every key draws like a little circle. Actually, I can press, because it takes some time for a key to fade out. I can even press it multiple times, and there will be like multiple circles on top of each other. And this is done in a. I think this is a really fun way to do it. So you, on the node on, we just pass in like a little function that captures everything here in a closure, and this function is what is executed when we call vdraw here. So it's.
Right. I can imagine if those weren't the circles but bars, then you basically get those MIDI visualizers that you can download for free, or or you can see
Oh
on the
yeah,
webs, like, just, jumping bars and stuff. One challenging thing that I see here is that there is a MIDI mapping you have to do. Like, you have to figure out what is the number of the note when it starts. Like,
yeah,
how does it map to your user interface? Maybe the value of the note will be outside of the screen, like.
yeah. Yeah, these are really tricky things, and I don't really think I have an answer to it because, yeah, I usually write these things for like, okay, I have this exact keyboard here, and
Right.
yeah, this software is not gonna leave this space. Um, but yes, there are good questions because uh, MIDI doesn't really, as far as I know, it doesn't allow you to query like what is the layout of your device. Like you can't really ask a device for like how many keys do you have or
Or one option is probably to somehow coerce the values into the available scale that you have on the screen, or
uh-huh.
that you're working with, and then say that somehow transform like the big scales into small scales with some formula. Maybe, I don't know, I'm just fantasizing right now, because I was playing with this API as well for a few days, and I also found that I found a few samples on the webs where the exact MIDI notes were hard coded, and then it didn't work with my controller. And then I
Yeah,
figured, aha, okay, now I have to actually change those values, change those constants, and then it started to work.
yeah, yeah. What you could do is at the beginning of a program, you could ask your user to touch like the leftmost key followed by the rightmost key, and then you know the range. Yeah, it's not pretty, but
Or have some sort of a database of all the MIDI devices
that's yeah,
with all the mappings.
yeah, that makes maybe more sense. Like well, there's a finite amount of MIDI controllers, luckily. So yeah, that's maybe a better solution than the thing that I just proposed. Yeah. Um, yeah. Well, I want to show some things that you can do here because now all the circles are in white. Would like to show how you could maybe make a color based on this node. Um, so I start with red, and we have a lot of we support a lot of color models. So we start with the color in RGB, and I convert that color to a color space that is called OKHSLA, which is like an HSL space, but with slightly better primitives for hue and saturation. They're supposed to be perceptually uniform. So that means that when you change the hue is like the actual only component that is changed in the color. Um, so when I change it to an HSL color, I can shift the hue, and I'm going to shift the hue by the node minus 48 times 360 divided by 31. And that
That's an
that
interesting formula.
well, there's 31 or 32 keys on here, and there's 360 degrees for an entire circle of the U. I just have to make this better. So yeah, it is like this: convert to HSL, shift the U, convert back to RGBA. So then we have this color value here. And before I draw the circle, I want to set the fill to that color that we have here. So now we should, yeah. Now we have
Ooh,
like a
nice.
nice rainbow of
Cool.
colors. Um, let's see. We can also, instead of applying this to the fill, we can apply this to a stroke and set like a stroke weight of 5. And then disable the fill entirely. Yeah. I just want to start with something. We see now a bit more shape because with the circles, they overlap and they hide each other. So we have a bit more shape. This height component, we could make this random. So for example, it could even be a bit wider. So now you see when I press the same key a couple of times, you see that for each press, it has like a random Y position.
Uh-huh.
So now, yeah, like we can make this like.
Nice.
Yeah, if I could actually play a keyboard, then I could play a song, and we would already have like a nice visualizer for the song that I would be playing.
Right. I can think of something like this goes for the melody, and if you have a drum machine that can communicate over MIDI, then for the
Mhm.
kick, you might have some effects like shaking the picture or something like that.
Yeah.
Just
Oh,
fantasizing again.
yeah. Sure. Well, let me get a bit to the part where we can do like some special effects, or like shaking the screen, or maybe do something like a blur, or um, actually we saw this before. I didn't explain what it was. So we have something that's called compose, and compose is a part of OpenRNDR that allows you to create sort of like layered documents. If you have worked with Photoshop, it works very much like that. We can make a layer, and on a layer we can apply effects, and these effects are all implemented in fragment shaders, so they are also they are fast. I used this before to work around a little bug that I had, but now I'm gonna use it for something good. So I make this composition, I make a layer, and the layer has a draw function that anything that I put here will be drawn. So actually, these circles that come from the tracker, I want to draw this in this composition in this layer. And now I draw this composition. So we should have exactly the same. That's correct. But now I can add a post effect. So let's see. One thing that I like a lot is laser blur. So now we see, let's reveal this whole
Ooh.
thing. Like now everything has like sort of like this radial blur like effect applied to it. Um,
Oh,
also,
oh,
yeah,
yeah, I was going to say that they look almost like colored bullets flying
I,
somewhere.
yeah, yeah. So we can I add these to the to the GUI here. So if there's something visible here, uh, I can change some settings of
Oh, nice. So
this effect.
the effect contains all the parameters, and you can automatically add it to the settings, and then everything
Yeah,
is rendered.
yeah, and
And
when it's
the only thing that is left is to map it into the control unit on your
yeah,
MIDI device, right?
yeah. So we can use this MIDI bind MIDI control. Then I use so there must be something that's called radius. Um, so probably this radius. Then I want to use MC, which is the rotary knob unit. And then, let's see, I would like to use...
That's really cool that you can program, then explore the device, immediately map it to the settings, kind of connect two worlds again, and see the result right away.
Yeah. So now it's yeah, and then I control this with
Really cool, really cool.
yeah, and there's a whole lot of other effects that you can apply to it. This one is also nice. It says need to have something on screen with lenses. Yeah, you sort of divide the image into a grid, and then for every grid cell, you change the scale of the image. So if I do this, you get this sort of this fragmented effect here, and you can also rotate each grid
Nice.
cell. Yeah, this
And
is
it's just almost no code. This is like amazing.
So I'll put this. So now I can Yay.
Just curious, do you have any effect that simulates the water drop, like the water circles when something drops in? And
I'm not sure. There is something that's called fluid distort. What? And it's not really doing what we want. But yeah, I get what you want. But this is doing something.
This is the effect that everybody, if you like it and you want to play with it and you want this effect, this is what you could contribute to the framework. Why not?
Yeah, exactly. All right. Well, I think I managed to this time actually show everything that I wanted to show. So that's
Perfect.
great.
I actually thought one little thing I could demonstrate as well. Why not? Because I also have the device right here, and I have a sample code
Oh,
that
cool.
I've written exploring these APIs. And
Uh-huh.
I thought I'm going to share my screen and share my screen somewhere, like the entire screen probably. Yeah. So here it comes. Let me bring it up to. Oh, sorry. Yeah, here it comes. So I found a sample. It's not written by me. It's written by someone called Megadix, and it was like it contained all the formulas and graphics already. So I did not add anything. I didn't change. What I wanted to do is to see how could I control it with my device, just to explore the framework and the APIs and so on. So I have this little device kind of combined with two versions of what you have. You have a big controller with the rotary and the keyboard, and I have pads, but basically they do the same. They are keys, right? So what I did, I downloaded the samples, updated the versions of Kotlin, of OpenRender framework, and so on, and I came up and I found a few mappings that I had to change with. Let's see where it was. Yeah, those constants, like the constants that you have to update, like because it was created for a specific device, and I have a different device with different mappings, and that's it. I didn't really change anything else besides the default device name. This is one thing you have to find out, how is it called, because even I have three different devices by the same vendor, they have a very different way of how they code them. Like sometimes they use capitalization, they sometimes they don't. Sometimes they put the vendor name into the device name, sometimes they don't. Like
Okay.
here,
Yeah.
I
I
have
think.
a K-Step Pro, which is by Arturia, but BeatStep is called Arturia BeatStep, which is
Yeah.
strange. Right. So I mapped it, and what I've got is that this visual I'm controlling with the four pads, and I'm going to like put it on the camera. So when I press, the color scheme changes, and this is like already like, oh, a big win. I like it very much. Something works, and this is how I can start exploring further.
Yeah.
What I found different between your presentations, like I learned a lot right now, because like the settings, how you can uh, bind the device to the settings is like it's such a time saver for this kind of coding. And the other thing is some of the APIs I haven't found like immediately. Maybe they are in the documentation. I was like this cowboy coder this time. I was just downloading the samples and trying to make them work. But otherwise, it's just
Yeah.
stunning what you can do with this.
Yeah,
Right.
well, I'm really happy to hear that you found work by someone else, and you could actually load it into IntelliJ, and it worked. That's really great.
With a few tweaks, I updated the versions, but yeah, like minimal updates. It worked really great. And so yeah, everybody like who was on the stream, and I hope people will watch it in the recording as well. We will put some effort into this, definitely. Uh, you have to explore this framework for creativeness, and there's definitely more in this framework than we showed. Like I was exploring what kind of features there are, and maybe we will continue one day with something else. One question I have to you is like, when you have done all those visuals and you have this controller, what's next? What could be next? Like where do you take this visual that you generate with a MIDI keyboard or MIDI device?
That's yeah, that's a good question. I think there's multiple answers to it. So um, actually, a thing that I would like to do a bit more is get into uh, doing performances. So actually, you go out there with a laptop and a MIDI controller, and you make visuals, and maybe even by writing the code on the spot, and yeah, just it's really like a performance. The other thing that is interesting. Um, would be if I can record the MIDI events, if I record them, and if I can replay them, I can use this to create videos, or to yeah, just like in general, like make animations. Sometimes when you make animations, like you can well, there's so many ways to make animations. You can really like hard code it. You can use like keyframers, or JSON files that include like yeah, which values you want to interpolate between, or you can do something that records yeah, key presses. That's also like a way to animate. And um, each of those methods have like different pros and cons. Like what I like about uh, sort of like live input is that it's yeah, it's made live, so it tends to have like a completely different feel from things that are entered in a JSON file, where there's it doesn't really relate to like the human motorics, or like the thing, like the amount of things that you can change at the same time, because you only have two hands. So that's
Hmm.
yeah,
Yeah,
there's interesting things you
I,
can do with it.
I have some friends who play electronic music and they use a lot of MIDI devices. and they go through a lot of work to actually create visuals for the performances. And I see how I can help them with this framework right now. Like, the reason I was asking about the hard coded values is that they have so many devices,
Mm.
and I would like for them to decide for themselves, like what kind of ranges they want to put in and what kind of mappings they want to create between the MIDI signals and the visuals. And this is a challenge because they wouldn't have the access to the code, right?
No.
Obviously, because they are not developers, they wouldn't write the code. But I see how I can simplify it for them by being able to generate the settings for them,
Yeah.
like, and with a very little effort, if I can know the device names like beforehand, then with a very little customization, I can give them a tool to perform. This is like a great feature that I can see here.
Yeah. Yeah.
Right.
Yeah, one quick thing for the layout configuration. I think it would be nice to introduce like a layer in between like the actual like the key and note or like the controller numbers and the note numbers. So you could make a file that gives every key a name, and then someone could in that file specify which note or controller that is, and then
Yeah,
it's
they usually have not a number but something like C1 or
mm,
like D4, like the
yeah,
number of the octave and the note itself, right?
yeah, yeah,
Cool. So I think we are right in time, like 1 hour session. It's not strict, but we made it. And thanks for coming again, Edwin. Let's keep in touch, and maybe we can come up with new ideas for the sessions. It seems that the people very like it, and yeah. Uh, Thanks everybody for watching it, and have a nice Kotlin.